Okay, so what we have been doing the past couple of days is, right, they've been giving us, not quite as big as this, right, they've been giving us a very large polynomial equation, and we have had to factor it, all right, factor it into all its parts in the parentheses, right, all its factors, and from the factors, right, we've been able to then extract or figure out what the zeros were, all right, what the zeros were. What we're going to do today is we're going to do this process backwards, all right, so what we're going to start with is they're going to tell us what the zeros are. We're going to take those zeros and put them back in what their factors would look like, and then we're going to multiply the factors back together so that we'll end up with like a long equation at the end. Now, none of the ones that we're going to do are going to be anywhere close to like this size, okay? So the fact that you saw one that's like x to the 6th and it goes on forever, all right, that's not what we're going to do. However, I came up with this one, and I figured out this one myself. I just picked zeros, and then I wanted to have some with some exponents on them, all right, so that, just so I could show you some stuff, all right, but regardless, okay, let's pretend that this was our problem, and we already factored it. All right, we did synthetic division lots of times. They would have had to given us lots of zeros. Us done synthetic division a bunch of times and then factored at the very end, right? And we got all these different factors. Now, there's actually only 3 different factors here, right? There's an x minus 1. Okay, and you see I wrote that again down here. All right, and then there was this x plus 3 factor that actually occurred 3 different times. Okay, all of this, when you multiply something times itself, but 3 different times, that's the same thing as saying it's cubed. All right, so instead of having to write it out all these times, you can just write it as x plus 3 cubed to the 3rd power. All right, and then so you can see I did the same thing here. All right, I got 2 factors that were both x minus 6, so I wrote it as x minus 6 squared, right? It's times itself, there's 2 of them, and that's why it's squared. Now, so there's really only 3 zeros for this polynomial, because there's 3 different factors, even though some of them repeat a bunch of times, okay? What would be the 0 that would come from the x minus 1 factor? What would x have to equal? Positive 1, exactly. It's the opposite, right, of what you see in the factor, right? This says a minus 1, right? So the 0 would actually be x equals positive 1, all right? I'm going to write that right there. All right, from this factor, right, we would have another 0, okay? X plus 3 gives us a 0 where x equals negative 3. All right, and from the last factor, x minus 6, we would get a 0 at x equals positive 6. All right, so those are actually the 3 unique factors that we have. Now, this is what's brand new to us. We haven't talked about this thing called multiplicity. All right, I'll give you a hint. The multiplicity is the exponent, is how many times that factor is repeated. All right, so the 0, right, that we got that was x equals positive 1, we're going to write that on here. All right, that factor only occurred once, right? when I listed them all out and showed all the repeats, it only occurred once, which is why right here you don't actually see a exponent written on the outside of the parentheses, because when it's to the first power, they don't write it. Usually it's one of those invisible math things, all right? So it's to the first power. So we say that its multiplicity is 1, right? Its multiplicity is 1 because it's to the first power. Now, different multiplicities actually tell you what the graph of this polynomial will do, all right, when you draw the graph. Okay, whenever there is a multiplicity of 1, I'll show you pictures of these in just a minute, but let's just write it down first. All right, whenever it's a multiplicity of 1, all the graph, or the line part of the graph, just passes through the point. All right, it's just going to pass through the point, right? It's going to go right through it. All right, I'll show you in picture form in just a minute. All right, now this factor, right, gave us the 0, x equals -3. So I'm going to write x equals -3. That was our second 0. All right, the multiplicity on that 0, right, is the exponent on the outside of its factor. So this time, this one has a multiplicity of 3. Right? The multiplicity on that 0 is going to be 3. Now, what happens when the multiplicity is 3 and actually, or if it's another odd number that's higher than that, or an odd number higher. So if the multiplicity was like 5 or 7, I mean, we won't really deal with numbers that high, but you know, it's worth mentioning, right? 3 or an odd number that's higher. All right, what happens is it goes through the point, but it does this little like curve through it. All right, this is a very technical mathematical term. I say that it wiggles. It wiggles through the point, okay? All right, I'll show you what that looks like, all right? It does a wiggle. Very technical term, all right? It wiggles through. Very high level math right there. All right? All right, and then the last one, okay, so when there was a 0, right, our last 0 was x equals 6, positive 6. All right, and the multiplicity on that factor, right, the exponent on the outside was a 2. All right, so 2. So if it is 2, or it could be any other even number that's higher. So it could be 4 or 6. If the multiplicity is 2, 4, 6, 8, you know, who do we appreciate, right? Or anything higher, even numbers higher than 2, all right, then what it will do on the graph at that point, all right, is it will bounce. It will bounce, all right? Yep. Okay, so now these aren't in order because I went 1, 3, 2, but I usually remember them in the 1, 2, 3 order. 1, 2, 3, pass, bounce, wiggle. 1, 2, 3, pass, bounce, wiggle. Like we could make like a dance or something to it, you know? Yeah, pass, bounce, wiggle. I don't know, something like that. All right, now let me show you what this looks like. Let me show you what they look like, okay? So as a reminder, a 0 is the same thing as an x-intercept, right? They could say, what is the 0? Or they could say, what is the x-intercept? That's the same thing. An x-intercept is actually a point that is on the x-axis of a graph, right? We have an x-axis and we have a y-axis. All right, so basically what would happen, all right, there is a point at x equals positive 1, right? So here's 0, here's positive 1 on my x-axis. I'm going to put a point right there. All right, that's that 0 x-intercept. Now, because it had a multiplicity of 1, we said it's just going to pass through that point. So if I was drawing a graph, right, my line would just pass right through it. It would just like cut right through the point. Does that make sense? That's what I mean by pass. All right, it would pass right through that point. I don't know what the rest of the graph would look like, but I know right there at that point, it would just pass right through it. All right, so that's the pass. Okay, now, I'm also going to have a point, right, or an x-intercept at -3 on the x-axis. So if I go over here, here was 0, right? Let's say this is -1, -2, -3, right? So I'm going to have a point right there, right at -3, all right? Because it had the multiplicity of 3, it's going to wiggle through that point, all right? Let me show you what it looks like when it wiggles, okay? So it does go in one side and out the other, but when it does a little curve and a curve. It does a little like juke, right? It's like, I'm going to go this way, psych, I kind of curve again and go this way, all right? Yeah, it doesn't go straight through, right? To me, it looks like a wiggle, right? It like kind of wiggles its way through.
Feels wavy.
Yeah, it waves its way through, right? Wiggle. It's wiggle to me. Bounce pass wiggle. All right. Okay, so we're going to wiggle. We wiggle through right there. That's the wiggle, kind of what it looks like. All right, the bounce. All right, at x equals 6. So positive 6 would be like way out here. All right, so this is what bounce looks like. All right, bounce is like a parabola. All right, it's like, okay, I'm coming towards the 6. All right, I'm going to hit the 6, but I'm actually going to bounce off the 6, and now I'm coming back up. Right? Doesn't it look like a parabola? Like a quadratic? All right, that's the bounce. All right, it's coming towards it. It actually hits it, but just bounces back the other direction.
Like a basketball.
Like a basketball, a ball hitting the floor. Right? It hits the floor and it bounces back up. All right, that's the bounce. Okay, so later on, not yet, right? But later on, we're actually going to like use the zeros and this multiplicity information plus some other things that we're going to learn about later, and this is probably going to be after Thanksgiving break, and we'll actually be able to sketch have a good idea and like sketch what like the whole graph looks like of like this giant polynomial, and it'll be like, wow, that polynomial looks like this, and you don't have to type it into Desmos or put it in a calculator to see the graph. You basically would know what it looks like because of these zeros and bounce pass wiggle stuff. Yeah, it's pretty crazy, right? Yeah. You may use the restroom. Actually, my honors class is a few lessons ahead of you. They're actually having their quiz today over polynomials, and the other day we were like using this stuff to draw the graph, and we drew one, and I was like, I think this is what it'll look like. It was like a crazy equation, like something like this, really long, and we typed it into Desmos, and our graphs were twins. We were like, whoa, we did it. It was really exciting. All right. I mean, not that exciting, but it was exciting for math, okay? It was. It was exciting. We figured out what it looked like without a calculator. All right. Okay, so here's what we're going to do. like I said, they're going to tell us the zeros, and they will also tell us if it bounces or passes or wiggles at those zeros, so that we can figure out if there's a multiplicity that goes on them. Because we would need to know that if we're going to multiply it together to get the final equation. We would need to know how many x plus 3 factors we're supposed to have. Do we have 3 of them? Do we have 1 of them? All right, hopefully 1 on most of them, all right? So, but they will tell us that, okay? So, here's what we're going to do. We're going to come up with a cubic polynomial. All right, what does it mean for our polynomial to be cubic? What does that cubic part tell us? That it's something to the 3rd power. All right, I don't know what the rest of our polynomial will look like, but it is going to have to start with an x to the 3rd. Right? When I write out the equation, it'll be like f of x equals x to the 3rd plus blah, 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 blah. It'll keep going from there, right? But it has to start, all right, with an x to the 3rd, because that's how you get a cubic polynomial, all right? Notice, all right, it's going to be an x to the 3rd, and they gave us 1, 2, 3 different zeros. You remember when we were finding the zeros ourselves, and when we're like, oh, the equation is an x to the 3rd, so how many zeros are we going to have in our final answer? And we would just look at the exponent and we'd say, oh, that means our final answer, we should have 3 different zeros. All right, so we have 3 different zeros right here. All right, all of them, it just says that it does a pass. All right, it passes through the x-axis at these numbers, -8, -3, and 1. So that means if it's just going to pass, that means our multiplicity is just going to be 1. So, all right, 1 is easy. All right. Okay, so here's how we're going to do this. I'm going to write down the 3 zeros that I have, and we're going to figure out what the factors looked like, all right, that those came from. So if our 0 was x equals -8, all right, what did the factor look like that we pulled that from? We're doing this backwards a little. -8 to the 3rd. We don't need a 3rd. The multiplicity is just 1. If it -8. Okay, so remember your factors all look like something like this with an x at the front. All right, so if our 0 was -8, what's the factor look like that it came from? X plus 8, exactly. It's still the opposite, right? This is what the factor looks like, and that's where you get the 0, -8 from. Does that make sense? All right, we're just working this a little backwards. All right? Okay, now, our next 0 was x equals 3. X equals -3, sorry. All right, so we need the factor that x equals -3 came from, which would be x plus 3. All right, and then last but not least, we had a third 0 that was x equals +4. All right, and that came from a factor that would be x minus 4. Right. All right, so now we have our factors. We said the multiplicity on them, since they all pass through them, are all 1. You can write a first power if you want, but remember, normally that to the first power is invisible. All right, so you don't have to write it there. All right, and so what we're going to do, now that we have the factors, is we're going to multiply them together. All right, we're going to multiply these 3 factors together, and that's going to give us our final equation. All right, yeah, remember we were taking an equation like this and we were having to factor or like divide it all apart. All right, well, what's the opposite of factoring or dividing? Multiplying, right? We're putting it all back together. All right, okay, we know how to multiply. We use boxes. All right, we're going to multiply. Multiply all together. Now, we can only really multiply with 2 at a time. We can only multiply 2 numbers at a time, really, on these 2 binomials, all right? So let's multiply these first 2 together first. All right, I'm going to draw myself a little box. I'm going to put x plus 8 on one side. All right, and I'm going to multiply it with x plus 3 on the, I'm going to put x plus 3 on the top, right? This is why we did a whole like quiz and test where we're just practicing like multiplying, adding, subtracting polynomials, right? Because we had to kind of know how to do this stuff first before we could do this cooler stuff, okay? Yeah, it's definitely cooler. Passing, bouncing, and wiggling is way cooler. All right, so x times x is x squared. All right, we're going to do 3 times x. That's 3x. All right, this square right here is an 8 times an x, which is 8x. All right, and then we got to do the numbers. What's 8 times 3? 24. All right, now, these 2 boxes, because they are x's, both just an x to the first, we can add those or combine those together, all right? So our answer, after multiplying these 2, is x squared. All right, once we combine these 2 squares together, that would give you 11x, so plus 11x. All right, and then the last one would be plus 24. Now, we're almost done-ish. We're close. All right, we have to do one more thing. What's that? We got to multiply it. We haven't multiplied with the x minus 4 factor yet. All right, so this is not my final answer. I'm going to take this answer that I've gotten so far. All right, I'm going to have to make a slightly bigger box because now it's a trinomial times the x minus 4 binomial on the side, right? So a 3 by 2 rectangle. All right, and we're going to multiply those together. Then we'll have done all 3, so we'll be finished at that point. Thank goodness, right? Okay. All right, so x times x squared is x cubed. All right, x times 11x is going to be 11x squared. All right, stop me if you're like not sure how I'm getting a particular number or something, okay? All right. 24 times x is 24x. All right, down here in this square, negative 4 times x squared is negative 4x squared. All right, this box is negative 4 times 11x. Negative 4 times 11 is negative 44. And then there's got to be an x on the end of that. All right, and then last but not least, just the number part times the number, negative 96. Yes, that's right. Negative 96, I think. Negative 4 times 24. I am pretty sure. I'm pretty positive. I don't have my calculator up here. Yes, I do. It's right here. I'm going to double, triple, quadruple check. Negative 4 times 24. Negative 96. We're good. We're good to go. All right, so my final answer is in these boxes. I just have to combine some boxes together. There's no other x cubes. Hey, remember what we said our final answer would have to start with? Because it was going to be a cubic polynomial when we got to the final answer. All right, it would have to start with a x cubed. Okay, then we can put together these x squareds. We have positive 11 and negative 4x squared, so that would be 7x squared. So plus 7x squared. All right, we're going to put together the negative 44 and the positive 24x. They're both just x's.
So 20.
Negative 20. It's a bigger negative number, so it's still got to be negative. Negative 20x. And then negative 96 at the end, because there's no other ones for that to combine with. Ta-da!
Big number.
But not nearly as big a polynomial as like this one up here, right?
The hexagon.
Yeah. To the 6th power? No. We're going to stick to cubics, quadratics, where like the front is just an x squared. That's pretty low. Cubic, x to the 3rd, maybe a quartic. X to the 4th, but we're not going any higher than that, all right? Too much. I'm telling you, it took me like 20 minutes to multiply that out. I did it. I have the paper at home. It's sitting on the little table next to my couch, where I just wrote out these factors, and I didn't know what this polynomial was to put on our notes, so I went and multiplied. They're like 5 boxes that are like ginormous all over this one like blank sheet of paper, all right, sitting in my living room, where I multiplied them back together. I hope I didn't make any mistakes. I think it multiplies to equal this, but I didn't check my work, so that's what I got. I had to get out my calculator too, because I was like 972. I had to like multiply some big numbers together.
Like
so.
almost 1,000.
Yeah. All right. Okay, number 2. So again, we're going to write a cubic polynomial. So our final answer is going to start like this one, right? A cubic is an x to the, that starts with an x to the 3rd at the front. All right, a cubic polynomial that's going to bounce at the root at 3. Root is just another word. We have so many words. The root is the same thing as the 0. All right, root, 0, x-intercept, right? They all mean the same thing, okay? They're interchangeable, all right? If you don't like the word root and you want to cross it out and write that's a 0, you can. You're not wrong, all right? If you're just like, I don't like the word root, right? That's fine, okay? So I'm going to start this one the same way I did the last one, all right? First, we just wrote down the zeros, all right? So there is a 0 at x equals 3. All right, and there's another 0. It passes through that 0, but there's another 0 at x equals 9. Those are the only 2 that we have. All right, now we want to write the factor that those zeros, or the factors that those zeros came from, right? So x equals 3 was the 0. It came from the factor, the little set of parentheses, x minus 3. All right, and this one came from a factor x minus 9. All right, now the only thing that's different on this one is that we have a pass which is a multiplicity of 1. All right, so it passes through x equals 9. So pass is a multiplicity of 1, so this just has to a first power on the outside. But this one, it bounces at 3. So that means it actually has a multiplicity of 2. All right, so this should actually be x minus 3 with a little squared on the outside. All right, the bounce, right, that's why we have our chart. Bounce is a multiplicity of 2 or an even number that's higher. We're just going to use 2. All right, we don't want to use even bigger numbers. All right, it's going to be 2 for us. All right, so bounce is a multiplicity of 2, so we got to do that. All right, so we're going to have to multiply this together. Now, here's what I'm going to multiply together first. I'm going to take care of this x minus 3 squared because, as a reminder, when you square something, that actually means there were 2 of them being multiplied together, right? Yeah. Okay, so I have to actually multiply together an x minus 3 times another x minus 3. And so we're going to do that with our box. All right, then we'll do times the x minus 9 last. All right, so x minus 3 on the side and x minus 3 on the top. All right, this won't be too hard to fill in. X times x is x squared. Negative 3 times x is negative 3x. Another negative 3 times x, so another negative 3x. And then what's negative 3 times negative 3? Positive 9. Excellent. All right, so x squared would go at the front. All right, these boxes, what's negative 3 and negative 3 added together? More negative. Negative 6. Yep, negative 6 x's. All right, and then the plus 9 at the end. All right, so now we've multiplied the bounce, the bounce factors together, right? There was 2 because of the bounce. All right, now we got to multiply it with the x minus 9 factor and we'll be finished. All right, so I'm going to keep this trinomial at the top. All right, and I'm going to write the x minus 9 factor down the side. All right, so x squared times x is x cubed. Negative 6x times x is going to be negative 6x squared. 9 times x is 9x. All right, down here, negative 9 times x squared is negative 9x squared. All right, now we got some numbers. Negative 9 times negative 6 is going to be 54. And then there's an x on that one, so 54x. And then negative 9 times positive 9, negative 81. 9 times 9 is 81. All right, so now we just need to write out our final answer. So it's going to start with x cubed again, right? Which we knew it was supposed to because our final answer should be a cubic polynomial. All right, so f of x equals. I'm only writing that because usually when you write the whole equation, you write the y equals, or remember f of x is the same thing as writing y. Okay, we're just saying it's a function by writing it that way. F of x equals x cubed at the front. All right, we can put the x squareds together. Negative 9 and negative 6 is negative 15. 9 and 6 is 15? Yeah. Negative 15x squared. All right, then we can also put the 54 and the 9 together. That's going to be 63, I believe. 63x. And then at the very end would be the minus 81. And that would be our final polynomial equation. This is basically what I gave you on your homework. I was like, here's your equation, and then I would tell you 1, 0, right? I forgot an x? Oh, I did. There's an x right there. Alright. I would basically give you this equation, and then I would tell you one of the zeros. Like, one of the zeros is x equals 3. And then you would do synthetic division and break it down. Right, and you would break it down into all the factors, and then you were able to tell me the other zeros.
Then you would have that.
Right? So now we're doing it backwards. We're starting with the zeros, we're turning it into factors, and then putting it back together to get the equation.
That's how we done it.
Yeah.
So like putting it, like gluing it together.
Yeah, we're building the equation.